Hello everyone, today we are doing some important theorem on limit. This is Cauchy first theorem on limit. This is very important for CSI net examination. Question based on this theorem always come in the examinations. Given the examination, if theorem is if limit n tends to infinity, fn equal to L. Okay, fn is a sequence, and then limit n tends to infinity, f1 plus f2 plus f3 and fn oblique n equal to L. Okay, now the theorem is Cauchy. This is called Cauchy's first theorem on limit. If limit n tends to infinity, fn, limit of sequence goes to L, then limit n tends to infinity, f1 plus f2, f3 plus fn oblique n equal to L. Okay, now we are taking some question based on this theorem. The question is limit n tends to infinity, 1 by n, 1 plus 2 raised to power 1 by 2, 3 raised to power 1 by 3 and plus n raised to power 1 by n equal to, we need to prove 1. Now we can see sequence is fn equal to, we can see 1 raised to power 1 by 2, 2 raised to power 1 by 2, 3 raised to power 1 by 2. So the n term of this is sequence is n raised to power 1 by n. Okay, now n raised to power 1 by n, and we have the theorem if limit n tends to infinity, fn, if the limit of sequence is L, so find limit of this sequence, limit n tends to infinity, n raised to power 1 by n. We need to find it. It is very easy. We know that the value of this is 1, but if you don't know, then we will find for you. We can take it as y equal to limit n tends to infinity, n raised to power 1 by n, then take log both sides, limit n tends to infinity, because we can see this is infinity raised to power 0 form. Okay, this is indeterminate form. So we can use, we can solve this by this way. Okay, now log n raised to power 1 by n. Now we can write it as 1 by n log n. Okay, now we can see log n, log infinity oblique infinity. This is in the infinity by infinity form. Okay, and when this is in infinity by infinity form, we can use differentiate numerator as well as denominator. Okay, because this is indeterminate form, infinity by infinity form is a indeterminate form, and for solving this type of indeterminate form, we differentiate numerator as well as denominator. Then differentiate of log n with respect to n is 1 by n, and differentiate of n with respect to n is 1. Now if we applying limit 1 by infinity equal to 0, log y equal to 0, and we can see y equal to e raised to power 0, the value of y, okay, the value of y equal to 1. Okay, so we know the theorem limit n tends to infinity, fn equal to L. Now value of L is 1. Now direct the some limit of this sequence equal to 1. So this is a very easy question. Now we solve some more question.